this video, we're going to focus on Python test-driven development. So the objective of this video is to help you explain TDD, write documentation of modules and function, and write TDD using Doctests, Pytest, and Unittest. What is TDD? TDD is a software development methodology that emphasizes writing tests before writing the actual code. It follows a specific cycle of writing tests, running them, and then writing the code to make the test pass. So we first write the test, then we run the tests. So the tests are going to fail because we have not implemented the code. Then we write our code. After writing our code, we expect all the tests to pass. If all the tests does not pass, we are going to refactor our code. After refactoring our code, we are going to run the test and we expect all the tests to pass. If it does not pass, we are going to refactor the code until all the tests pass. So let us check this example. Let us now see an example. So in this example, I'm going to create a module called my module. I'm going to call it my module, and in this my module, I'm going to create a function. A function will be called an add function, and this add function is going to return the sum of two numbers. I already created the folder. Let us check it. ls. I already created a folder and call it test units. So let us cd into our directory. So we have created our parent folder. It's called test unit. We are also required to create a subfolder called tests. I've also created it. We have a folder called tests. This test will hold all our test files will be inside here. So since in this video we're going to focus on Doctest, Pytest, and Unittest, we're going to start with let us start with the Doctest. So our folder tests, I have already written the Doctest test. Let's check it. So I've called it doctest add doctest.txt. So let us check it. In this example, I've written the name of the module that I'm going to use. That module, I will also have a function that is called add function. So the first name is the name of the module, the second is the name of the function. So my function will be called add function. After having documented those two things, let us now import the add function so that we can test our function. So we write import, then the name of the module. Our module be called my module, and then the name of the function that we want to import. In this case, we are importing the add function. So we have our add function. So from this add function, we can now test it. So these are some of the examples that I came up with. So the first example, I was testing adding two integer values, an integer 2 and 2, and I expect the first value to give us 4. The second example that I came up with is testing a negative number and a positive number. So I expect it to have the result to be 8. The third example I came up with is when user decided to provide a string and a integer. So when a user provide a string and integer, I expect a type error exception to be raised, and this message, so a must be an integer or a float. I'm going to check if when a user provide a string, a type error is raised and it has this message, a must be an integer and float. Same case apply when user decided to provide only one of the parameters and does not provide the other one. We expect also a type error that's going add is missing one required positional argument, which is b, because only one one argument is provided. So these are some of the examples that I came up with. So let us save it. You can also add extra. So I'm in the parent directory. So let me run the test. We expect that we expect all the tests to fail because we have not implemented the code. So all tests are going to fail. Let us check it. Python 3. The name of the module we are going to use, Doctest. Also need to see what is happening. So the name of the folder, tests. Then we have saved in the name of the Doctest. You can check here at the bottom. You have 0 passed and 5 failed. So we are on the right track. 0 have passed and we have 5 have failed. So let us implement my module now. I've already implemented it, most of the code. My module is going to be implemented in the parent directory. So in this, we need to learn the first 2 things that are very important. The first thing you need to do, we need to write our shebang. This is called shebang. The first line is called shebang. We need to start with the shebang. That's the first thing. When you write a module, the first thing you need to start with is shebang. After writing the shebang, before you import anything else, you need to document the module. So in this, I have written a small description of what this module entails. So these modules contain the add function only. You can write anything to describe what this module contains. So after writing that, you can see we have this is the documentation of module. We can also check it. Let us go back. We can also check it. You need also to check if the documentation of the module exists. You can also check it like this. Python 3.c. Need to print. Let's print. Print import. Name of the module. String. Pass a string. Then we need to pass the doc. Like that. Press enter. You can see that the documentation of the module is present. You can see this module contains the add. This module contains the add function only. Let's go back to our module. So then the next thing we need to do is to implement our add function. So that you write the name of the function is called def add. It has 2 parameters, a and b. So after writing the name of the function, you need to document the function. The first thing you write when documenting the function, you must use 3 and end with the 3 quotation. So this function, I've written a small description. This function adds 2 numbers, and the numbers can be an integer or a float. So you have 2 arguments. You write the argument, then you write the type. In this example, I've written the type. It can be an integer or a float, and this will be our first numbers. The second, we have b, which can also be an integer or a float. which will also be our second number. Then this function called R returns an integer, which will be the sum of the sum of the A and B. And also we can write an example. So when you write, we can add. When we write 3 and 3, we expect the results to be 6. So this is the format that you should use when documenting your model. A description of the function, the arguments. After writing the argument, it returns, and also you can write an example. You can write your example. After documenting the model, we can also check. Let us check if the documentation is present. Just check it. We can add the function there like that. Yes, the documentation of the model of the function is present. This function adds two numbers. We have our arguments A and B. The return is an integer, and so we have provided an example. Let's go back to. So let us implement the function now. In this function, I'm going to check two things. Our add function will accept only an integer and a float. So we need to ensure that no other type is allowed. So if not is instance of A is an integer and not instance A a float, we raise the type error. A must be an integer. A must be an integer or a float. This is the message that I showed you in the document. They must be equal. This one is the message that I showed you in the Doctests. They must be equal. When raising the type error, you must provide the same message in your Doctest. So let me explain this statement here. So for example, let us say our A is an integer. So in this, let us check if our A, if a user provided a 3 as an example. So A will be an integer. So is instance A an integer? This will be true. Because we have not here, it will be converted to false. Then we have the other statement on the other side. Is instant A a float? This will be false because it is an integer, and because of not, it will be converted to true. So true and false returns false. So this type error will not be raised. Let us take an example. When user provided a string, let us say here the user has provided a string. It's an example. The user has provided a string. So we know that A is a string. So if not, so is instance A an integer? No, it is false. This one is return false. So false, because of this not, it will be converted to true. On the other side, we have the same. Is A an instance of float? It is false because it is an instance of a string. So because this is false, it will be converted to, because of not, to be converted to true. After being converted to true, so true and true results to true, and this error, this exception will be raised. The type error exception will be raised. The same case as the way I have explained for A happens to B. So if user provided a float, the float will be converted to an integer. If B was provided as a float, it will be converted to integer, and our function will return A plus B. So let us save it. So let us try again. Let us test. So we expect all our tests to pass. Five tests have passed and 0 have failed. So that is an example of using Doctest. Let us check the second thing. We're going to check for the unit test. Let us first change our module. that all our tests will not, don't expect them to pass on our first try, because we need to let us take for Pytest. Name a folder, tests, test add Pytest. It is the same as the other one. We must start with our shebang. We start with our shebang. Then after our shebang, we import the Pytest, because in this case we are going to use our Pytest. Then we need to import the sys. The reason why I've imported the sys is because the module and this test are not in the same folder. The module is in the previous folder, while the test is in the subfolder called test, and my module is in the parent directory. So they are not in the same folder. So we need to append the directory where our module is located. So since we are going we are going to test when we are located in the parent directory, we need to include the current. This full stop shows the current. We need to include the current folder or directory. We need to include this, includes the current directory. So after including the current directory, we'll be able now to import the add function. Without adding this, we receive an error, because it will not be able to import the module. So after setting the path, now we can import our add. We can import our add. Then I decided to use class so that I can group. This class helps us to group all our tests. I'm able to group all of them. So in this first case, the same case like the other one. So I decided to add two numbers, 2 and 2. In our case, 2 and 2. Then we use self. Then we assert add 2 and 2 is equals to 4. So we expect that 2 plus 2 is equals to 4. I also tried using two negative numbers, -2 and -2. Expect our answer to be -4. Another example that I came about is adding a float and an integer. So we expect the value to be 5. And why 5? Because the 2.5 will be converted to an integer, which is 2 plus d equals to 1.5. So also, when the user provided a string, this is a string, provided a string, we expect that type error to be raised. So in this case, we will say with Pytest raises. In this case, if we want to confirm any type error, any exception was raised, we use with Pytest.raises. We must use like this. And we provide the function that is going to raise this type error. So in this case, it is adding an integer and a string going to raise a type error. Let us test it. We say Pytest. And the location, that's the v flag. So because we have not implemented the add function, we have received this error. Let us implement the add function. Go back to our module. Let's try again. We have implemented our module. So all our 4 tests have passed. Lastly, let's check our final unit test. Let's first change the module. You can change here the module. Let's check our unit test. Go to our folder. Our unit test is different. But we always start with our shebang. Import our shebang. We add our shebang. Then you need to import the unit test. After importing the unit test, we also need to import the add function so that we can use the add function from the module. We're going to import the add function. Then in this case, we are going to extend the test class of the unit test. You have to pass this when using unit test in our class. If you don't provide this, it is not going to work. So our first test, it is the same as the Pytest. Are going to assert two numbers, 2 and 2, it is equal to 4. So in this case, you have to start with the self. You start with the self dot assert equal. Yes, you can go and check their documentation. There's so many assertion that the assertion method provided the test case from the unit test. So in this case, we are going to use the assert equal. We want to assert that add 2 plus 2 is going to be equal to 4. That's the first example I came up with. So the second one, we need to assert that when adding 2 negative numbers, we get a negative number. So we say pass self. So to test add negatives, that's 2 negative numbers. So we say self dot assert equal add negative 2 and negative 2. Expect the answer to be negative 4. The third example I came up with is adding an integer and a float. So for example, if a user provides 2 and 3.4, we expect the answer to be 5, because in our implementation of our add function, we convert every float provided to be an integer. So when you convert 3.5 into an integer, we're going to get 3. 3 plus 2, we expect the answer to be 4. Then we also need to assert races. This is another method that is provided. We have assert races when we want to confirm a type error, a particular exception. So in this case, we want to ensure that a type error was raised. So we confirm with assert races method, whereby we provide the exception that you need to confirm, and the name of the function. This is the add function. We're going to add our add function. Then we provided the variable, the parameters. In this case, we have two parameters. So the first parameter that was provided is a string, and the second parameter is an integer. So when you add a string and an integer, we expect a type error exception to be raised. Then at the end, you must include this. So if main equals, if underscore name underscore is equals to main, we call the Unittest dot main. So that is how you implement a unit test. So let us save it. Yes, check it, Python. The module you are going to use is Unittest. The location of the failed. They have failed all of them. Let's now implement our module. I provide you with this code. I will provide you with a link to my GitHub with this code for reference. Let's try again. All tests were run and all of them are okay. So that is the end of this video. I'll provide you with a link to my GitHub, and it will contain all the documents and this file that we have used in this video. Thank you very much.